in January 2012, right? So he helped us start this whole group, and it's glad to see you around. Glad to see that. So tonight we're going to have a couple of presentations, one by PLUMgrid, another one by Pivotal on Cloud Foundry. Hey guys, let's keep the noise now, or else we will be punished.
Take away your beer.
No beer for you. Okay, so we are Meetup.com. We are linked, we meaning OpenStack machine. So we are on Meetup.com. Join us. We are on Twitter. ECTech is the hashtag. OpenStack is the hashtag also. And join the LinkedIn group. And on the right side are the PLUMgrid, Pivotal, Cloud Foundry Twitter handles. And Valentina will tell us how the name PLUMgrid came about. It's pretty interesting. And January 28th, there is a Cloud Foundry community meetup in Reston, Virginia. So I'm interested in this, and I think others might be. This is an addendum to what's going to be presented today. And I think it's hands-on. Who's the gentleman telling?
Yes, so it's hands-on. Mike Dolan here, all guys. We do these on a monthly basis. As said, we have 15 people or so that can come to sign up. Josh has got a link to the presentation. He's going to share. We'll take your registration fee. You can come spend a day for free. There's food, and learn how Cloud Foundry works, and actually get a chance to work with technology directly. And Josh is going to share a lot more today about how that works. So.
Excellent, thank you. And today's agenda, we have, of course, meet, greet, meet, the big geeks. And we're going to have two presentations, one by Ms. Valentina Laria on OpenStack networking features, gotchas, and best practices, and Joshua McKenty will present on Cloud Foundry, which is a platform as a service on OpenStack. And here's some verbiage on each presenter. I will come back to that in a moment. But upcoming events, next Wednesday, right over here, we have another event by Open Storage. And then March 10th, we have another one, OpenStack Trove project. So do RSVP to these two. Next week, Wednesdays, is on Wednesday in the same venue. On March, it's in the Uber offices in DuPont Circle, just a few miles west of here. And do RSVP to that, please. And here are the organizers. The others are not here tonight. And of course, we should do this, right? The convention center is only 3 blocks north of here. And so let's come back to Ms. Valentina Laria, who serves as the head of product and solution marketing for PLUMgrid. And you could read the bullets. It's a pretty amazing background. And I hear you ride a Vespa.
I do.
Okay. With a leather jacket.
Obviously.
My inside sources said. And I guess without further ado, you could start.
Valentina. Yeah.
Do you need to play music?
Yep. I'll just share my. We're also sharing the slides on WebEx. Perfect. Well, thanks everyone. Was that? Oh, the mic. I'm loud. Do I need the mic? Okay. Can you guys hear me in the back? I should use the mic? I'll use the mic. All right. All right, so welcome everybody. Thanks for coming over. My name is Valentina Laria, and I've been at PLUMgrid for about 3 years, so pretty much from the beginning of the company. So what I'm going to do tonight is talk a little bit about OpenStack networking, and then what PLUMgrid does, which clearly fits within the realm of OpenStack networking and that layer of the stack there. So before I start, I think for the benefit of myself and Josh, can I get a quick show hands of people that have been already installing OpenStack and have an understanding of the networking layer? Somebody? All right. So I would say 50% do understand that layer and 50% are pretty new. So what I'll try to do, just to bridge the gap for those that are new, I'll go through some of the basic concepts without spending too much time, just to get everybody to kind of get to the same level. And then we'll talk a little more about some of the advanced topics and show what PLUMgrid does in that space. I have about an hour, right, 40 minutes?
Yeah,
okay, perfect. It's all good. Yeah, all right. All right, so first of all, let me start with the story of the name PLUMgrid, since it was just talking about it. It's a very geeky story, so pardon me if I go very technical there, but so the idea of PLUMgrid is that when the company was started, we wanted to create something that could really transform how networking is delivered to the users. Not just a point product, but a big vision for a platform that could take customers through the next 15 years in terms of services and functions that need to get delivered on that software layer. And so the idea is that we wanted to create a data plane that was very flexible, programmable, and extensible. It could handle any type of traffic and any type of problem. And so the idea is we took, we looked at what the basic operations that are needed on a packet are, and those are 4, and it's the ability to parse, look up, update, and modify, and that's the PLUM. And then, in a cloud environment, you wanted flexible, programmable data plane to be fully distributed, and that's why it's a grid. So PLUMgrid, that's kind of the story of the company name. And you see, as we talk about what we do, PLUMgrid is a software on infrastructure. So, obviously, why are customers looking at OpenStack? I shouldn't be telling this crowd. You all are obviously here for a reason. You probably are either, on the customer side looking at how to transform your own infrastructure, or if you're a vendor or a solution provider, you clearly understand that there is a need for a transformation of how infrastructure is delivered. And obviously, we see OpenStack being well positioned to achieve and enable this transformation. This one slide, again, not necessarily for this crowd, but clearly shows some of the stats around OpenStack and the amazing growth that we're seeing in this community. How many of you were at the last summit in Paris? Well, if any of you, not many, but if any of you have been at that summit and also some of the previous ones, you can probably witness the amazing transformation and the complete, growth that we have seen in the community, going from, 50 people 4 years back to 6,000 or so attendees in Paris. So certainly this community is growing, and we see, which is very important for us, we see a larger number of use cases being built on top of OpenStack. And I'm very pleased that kind of the follow-up to my presentation is going to be around platform as a service and what Cloud Foundry enables on OpenStack, because that's one of the major applications and use cases for this platform. Now, when you look at building an OpenStack cloud, there is one component that happens to be kind of the junction of everything, and that's the network. The reason why it's at the junction of everything is because that's how you really provide connectivity. You provide connectivity between compute elements. You provide connectivity to your storage infrastructure. And it's also how you provide isolation. So there's these two contrasting requirements of, enabling entities to talk and exchange information while providing a very secure, isolated, multi-tenant sort of infrastructure. And at the same time, again, you want to be able to reach your storage infrastructure, which is often shared and something that multiple tenants can leverage at the same time, and provide some multi-tenant solutions for your compute layers. So we'll talk a little about, some of the requirements for the network infrastructure, and I'm going to start from a, very generic, high-level point of view. I don't know if the slides look that good, but you guys at least can see. But the idea here is that when you, as a user of OpenStack, start playing with this architecture and this technology, you should consider the network infrastructure architecture as a fundamental piece of your design. So the claim that we make is that regardless of the choice you end up making down the road, the initial consideration of which architecture is right for your environment is fundamental. The network plays a very important role, and if you choose the wrong architecture from the start, it might be something that satisfies the requirement of a very small initial deployment. We see a lot of users starting from 5 servers, 10 servers, but what you need to look at is what's the end goal of your deployment. Are you looking at growing beyond that very small initial installation and going to multi-rack, multi-site? So those are hopefully some talking points for you, internally within your organization. I was just talking to some of you as users who are just, getting started in evaluating OpenStack and understanding how to use it. So this is meant for you to, have a conversation internally within your teams and start discussing what are the requirements that our organization has for the network infrastructure layer. So if you look at this slide, it goes from the performance. The performance is, it's an interesting conversation to have. Lots of things are changing in the way the network gets delivered in OpenStack, and we'll talk a lot about how PLUMgrid, as an example, brings networking software. So when you come from a more traditional networking background of the network being physical boxes, the concept of performance changes. And that's something that you need to, again, evaluate internally and understand what type of application am I running? Do I need a solution that can just provide some basic feature and functionality, and those can run as a VM somewhere so I can maybe get a gig out of it? Or do I need something that can scale with my infrastructure and perform with my infrastructure, giving me tens of gigabit of throughput? So that's kind of the first bullet up there. The second consideration that you have to go through is from a scalability perspective. Are you going to start with, right away a very large deployment? No, as I said earlier, a lot of you are probably going to start from a handful of servers. But again, what's the growth and what's the path of your deployment moving forward? The network is something that is actually quite tricky to extend beyond a handful of servers if you don't think it through properly. And so again, do you want the ability of going, beyond a single rack? Do you want the ability to go beyond a single OpenStack cell, OpenStack kind of installation? The third point here is high availability. Again, the network model changes quite a bit. It becomes softer. It becomes integrated within OpenStack. And so when you look at how your network is highly available and is resilient to failures, you need to start considering different components that are not commonly what you would consider on a physical infrastructure. So you need to look at, is my control plane resilient? Is my data plane capable of tolerating failures? How do I interact with a failure of OpenStack, per se, of the main cloud management system? And then the fourth bullet is a very interesting one, and this is something where we spend quite a bit of time, Kelly, myself, and Fernando, which are the other two PLUMgrid members here, spend quite a bit of time on the road talking to customers, and a lot of them tell us that, hey, OpenStack looks great, there's a lot of adoption out there, but hey, I'm a cloud provider, I'm building a service on top of OpenStack, and I want to be competitive. And so how can I choose components that give me an edge, give me the ability to build advanced services and grow and change as the needs of my users evolve? So again, as you look at the OpenStack architecture and how you can leverage different vendors underneath. OpenStack was really built for this extensibility. From the beginning, it was modular architecture where you can leverage different plugins, different components. And as vendors in the OpenStack community, we see a big need for the ability to differentiate beyond the very kind of basic set of features that are commonly present everywhere. Is there any question? Please jump in, make it interactive. I'm not here to talk to myself for an hour, so hopefully somebody will have some thoughts they can share. But this was again, the reason I wanted to show you this is to use it as bullet points when you discuss internally. Hopefully it's something that can help you in your evaluation of the network layer vendors and options that are out there. And if anybody has gone through a selection of a vendor, I would love to hear if those are the criteria you applied for your choice or not. Anybody want to share their experience? You're a quiet crowd. All right. More beer? All righty. So since a few of you were brand new to OpenStack and the networking architecture, I'm going to touch a little bit of how it actually works and how it's designed. Hopefully, I'm not going to bore the ones that do understand how it works. So clearly, OpenStack has multiple components, and those of you that are familiar with the community have seen these graphs and the next one. But this is just to show that there is multiple pieces that work together. Those are some of the kind of initial big building blocks. If you're familiar with the evolution of the community and all that is happening, especially in the last summit, there is now a proliferation of what are called projects and kind of core components of OpenStack. So this is really by no means an exhaustive picture of all the moving parts that are now present in OpenStack. But when we talk about the network components, and we're also going to show you like a quick video. Fernando will jump into the presentation later on and show you kind of a quick demo of how it all comes together. But the components that are relevant for this conversation are always interaction between the network and the compute piece. And then as we talk with Josh, will cover some of the path infrastructure. You see obviously the storage and the API layer, how it all comes together. But the network piece was originally, and I'll show you this very scary picture, was originally part of the compute component. This is Nova. This is a very old picture representation, which now is actually completely different. But the reason why I like it is because it shows where networking used to be. So when it came out, it was a very small component of Nova, the compute part. Now what happened down the road is that as users started leveraging OpenStack and building applications on top of it, they figured out that Nova was not quite as capable as they needed it to be. So Nova was really meant to provide extremely basic connectivity, network connectivity between different nodes. It was not meant to satisfy, advanced multi-tenant, bridge topology kind of requirements. So that's where Neutron came into the picture. And if you were at the last summit, there were quite a bit of conversations around how do we actually get some of the large deployments that are out there that are running on Nova to migrate over to Neutron. So there's a big discussion going on around how do we obsolete Nova and how do we create a migration path out of Nova into Neutron. So what we'll concentrate mostly tonight is going to be around Neutron, but I'll tell you a little bit about kind of a comparison of what you can do with Nova and why you should, why you could consider Nova as a solution for your deployment, and why you should consider Neutron for anything that is more, again, complex and advanced in terms of use cases. Now, before we jump into the architecture, I just want to show you a couple of slides and get a little bit of terminology in place. Because you hear me talk about it, and I want to make sure we all speak the same language. So this is a very ugly, pardon me, I made this, representation of a compute node. If any of you that is familiar with Linux understand that there is a kernel and kernel space and user space. Now, when we talk about the network component in OpenStack, there's kind of a couple of ways in which, well, there's more than a couple of ways. There's, I think, three big ways in which you can consume networking, which networking can be made available to the end user. One is you use the traditional physical network infrastructure. You have your Cisco gear, Juniper gear, Brocade gear, whatever you want to have out there. You use that, and what you do through OpenStack is you go and configure and manipulate your physical infrastructure. But what we're going to spend most of our time today is talking about the ability to actually deliver the network in software, what we call the virtual network infrastructure. And when you talk about virtual network infrastructure, the way it gets delivered into the compute node is in two form factors. One is it's a kernel module, so it's a piece of code that kind of gets dynamically inserted within the kernel that provides the feature, the networking feature and functionality directly to the VM. And these, if you're familiar with Linux architecture, this is kind of the best performance possible way of getting this feature and functionality because it's running the kernel, has no performance implications, you need to contact it up to user space. Another way to consume feature and functionality is instead to run it as kind of as a VM, so in user space. And we'll talk a little bit about both models and why one gets leveraged versus the other, and what are the implications on your consumption and performance and type of use cases built on top of it. Something else that you hear us talk about, especially when Fernando shows the video, there's kind of two types of networks that you can build with OpenStack. And for the most part, what is interesting for users is the ability to build tenant networks. So what is revolutionary about OpenStack is that OpenStack enables users of a cloud infrastructure to self-service provision networks. And that's something that has never been possible before. So you have a user that logs into your cloud portal, and they can create their own environment. And they can define that they want these many VMs, and they want these VMs to be connected through some topology, network topology. And on top of that, you can specify which IP addresses you want to assign to these VMs, and what type of security policies you want to apply to those, and how they can connect and interact with each other. And all this, again, is done through this very powerful API layer that OpenStack exposes for through the graphical interface of OpenStack. And as we talk about what Neutron can do versus what Nova can do, this is where the big difference is in terms of how rich and complex these tenant networks can be, and what level of flexibility you can give to the OpenStack users in terms of being able to define what type of infrastructure they want to use for themselves. And then the other component is you still have an external network, something that is already there, exists, and it's usually something you need to be able to connect to. Example is you want to be able to connect to the internet or vice versa, you want to have a client sitting out there being able to connect to your web server, which sits in an OpenStack cloud. And that's where the concept of external network comes into the picture, and the ability to kind of glue together this new world of multi-tenant networks all in software in OpenStack with existing physical network infrastructure. So when you look at deploying OpenStack and you look at understanding, okay, wait a second, how many networks am I going to have? For the most part, if you leverage most of the Neutron plugin solutions that are available out there, you're going to end up having kind of two buckets of networks. You're going to have your existing physical network infrastructure, and that's again your physical gear, your existing gear that you have purchased, it's in data center, and it's now in charge of providing connectivity, bandwidth, designed to have low latency, high bandwidth, best QoS as possible. And then now on top of it, you have this new model of deploying and consuming networks, which is we call the virtual network. And for the most part, most of the vendors out there doing PLUMgrid, the way we bring this new layer is by leveraging what's called an overlay network. I was just talking to somebody that was saying, that these overlay technologies are a little confusing. But the very simple way to think about it is you all understand the concept of a hypervisor on the compute layer. You have your hardware, and you have your VMs on top of it, and you have some form of abstraction layer in the middle, which is a hypervisor, which enables a VM to run on top of any hardware. Think about it in the same broad terms in the same way here. You have your physical infrastructure, you have some form of software abstraction layer, which is what we call the overlay network. Then on top of it, you have the ability to create tenant networks, which are now completely decoupled from the underlying infrastructure. And that's kind of the beauty of it. Now, why is that beautiful and why is that powerful? Well, I mean, if you're running a cloud infrastructure and hopefully you're being very successful, you have a very large number of tenants coming into your cloud portal, the amount of changes in terms of creating new tenant networks, provisioning new infrastructure, spinning up IPs, destroying IPs, moving things around, it's pretty high. And you want to be able to satisfy the requirements of your users as they come. Now, if every time a new tenant comes in, you need to go and patch their physical infrastructure, that's pretty painful. It's painful and it's dangerous because if you mess up something, there is a very nice error propagation property of the physical infrastructure where you can potentially take down the whole thing. So the power of this model is that to decouple the two, you provision these isolated environments for your tenants in the kind of the software space. Exactly as a VM is an isolated unit, and you can assign them to different users. So more and more, when you are a network architect for a cloud, you have to handle these two layers concurrently and understand that properties and behavior of the physical infrastructure and its interaction with the virtual infrastructure. Any question on this? This is kind of a critical pivotal point of the whole conversation. So if it's not clear, I'm happy to expand on that.
Can you explain the two flavors of the network?
Yeah, so this is a PLUMgrid representation, and I can kind of give you an idea of what I'm representing this way. So PLUMgrid has a very particular technology and solution in this overlay network, and provides what we call virtual domains. So the way to think about a virtual domain is think about it as an Amazon VPC or a private data center that you can spin up for yourself. It's a completely isolated environment. It's isolated through VXLAN encapsulation or some form of standard encapsulation. And as part of the virtual domain, PLUMgrid gives you the ability to define any arbitrary network topology. So these are just two examples of two virtual domains you can create through the PLUMgrid product, PLUMgrid ONS. And as part of that, you can define any arbitrary topology. So in this example here, you have two tenant networks, two virtual domains. They are completely isolated. You can have their own overlapping IP space. And on the left-hand side, you have a very simple network. We have the bridge, the switch, layer 2 segment. You have some routing and some firewalling functionality. On the other side, you have much more complex network. We have your switching infrastructure, so two separate subnets with two separate IP spaces, some routing in between, load balancing, and firewalling. And this gives you just an idea of kind of the flexibility of what you can do through the PLUMgrid layer. Now remember, this is all done in software, and we'll talk a little more in terms of where that happens, where the magic happens. But to give you an idea, everything you do through PLUMgrid, all these switching, routing, load balancing, and firewalling, kind of gets distributed magically inside the kernel. So inside your compute node, we have a layer that we call IOvisor, which is a software layer that sits in the kernel module. That gives you all these switching, routing, load balancing, and firewalling fully distributed. But I'll rewind and show you a little more gradually, because this is kind of a leap of faith that I'm asking you to take with me, but this is kind of the idea there.
Can you create peering arrangements between those domains?
You can do all sorts of interesting things. You can have routers that can be used as the exit point of, actually, Fernando in the demo has some more advanced routing entities that you can use to have virtual domains to interconnect with each other. So virtual domains are kind of Lego blocks. And inside virtual domains, the smaller Lego block is what we call a virtual network function, which is the purple icons there. And you can kind of compose them. Yeah, so the virtual network functions, which are these icons here, those can be composed in any topology. They can be used to interconnect domains. We actually use, we interconnect virtual domains all the time. When you create a tenant network and you give this tenant network external connectivity, we always have the tenant virtual domain interconnect with kind of an external virtual domain. We can use virtual domains to create the under cloud infrastructure. So virtual domains are very, very powerful, even beyond what OpenStack offers through Neutron.
Is that something you can use to bridge legacy physical networking using VXLAN?
Yep.
But using VXLAN on physical switches, bare metal servers,
yep.
You have a way to bridge that into
yep.
the SDN environment?
Yeah, so the way PLUMgrid works is we are a software layer that can sit even within a bare metal server. It's just a kernel that sits within, Linux. A kernel module sits within your Linux kernel. We can work with partners that have hardware solutions, like hardware VXLAN termination, like we partner with Arista. It's one of our partners that we publicly talk about, where we can have them provide termination for VXLAN. And again, because it's a software layer, we can sit within your existing ESX environment, we can sit within your new KVM environment. So the idea is that we can stretch this SDN layer across pretty much any of your compute layers and provide this connectivity.
I was kind of looking at it more in terms of using something like Ironic, where you wouldn't necessarily have a hypervisor.
Yeah.
OpenV's was running it,
Yeah.
and that sort of thing.
Yeah.
No hooked up.
Yeah. Yeah, absolutely. You could leverage it in that way as well. Any other questions? Yes.
You mentioned you partner with OpenStack. There's some type of integration.
Yeah, absolutely. So let me get to the PLUMgrid slide, and then I'll show you where. But the idea is that any overlay technology is kind of a generic concept. Any overlay technology needs an exit point from the overlay magic world into the physical legacy network, and that's usually what is called a gateway. It's not a PLUMgrid terminology, this is VXLAN common terminology. So this gateway, it's kind of a device that sits in two worlds, and on one side fixed overlay technology, on the other side fixed VLANs or layer 3, whatever your network design is. And so this gateway can be usually a software device, so something that just deploys the software image on a server, or it can be a VXLAN hardware capable switch, like Arista, for example, is one of those that have VXLAN termination hardware. And so in particular for PLUMgrid, we leverage them as one of the options as gateway. So they can kind of translate between the overlay world and the physical legacy infrastructure. Yes? Yes, absolutely. As long as it stays VXLAN, we can work with any. Just a matter of customers wanting to one vendor versus the other, and us being a small startup, so you're very conscious of resources. Good.
Layer 2 overlay or layer 3 overlay?
So the Foundry can be anything. That's the beauty of it.
Personal opinion. This always
Layer 3 underlay, absolutely. I mean, if you have to design it, layer 3 all the way to the edge, and
layer 3 removes from the
exactly.
We allocate subnets and networks. We said the layer 3 removes the possibility of any loops and spanning tree, any problems in the network that you need to carefully plan ahead. The subnet allocation per rack per port, so you need to do a pre-allocation of all of that. Layer 2, you can just grow it massively and everything's flat. But you need to be careful with the loops and servers.
The beauty of those architectures is that you can take what you have and make it cloud ready, so we don't require any changes to the existing infrastructure. And if you're designing new environments, then you can decide to go again with layer 3 if that's, again, as Fernando was saying, the choice. We personally see a lot of customers designing new fabrics and using layer 3, but again, it's kind of a personal decision there. All right, so I don't want to eat into Josh's time. So very quickly, why was Neutron created? And I'll keep this on slide because we spent quite a bit of time on a lot of things. So why was Neutron created? So Neutron started as a project because I kind of mentioned it earlier, because of the need for a more rich and extensive network functionality. From the beginning, something that was fundamental to the Neutron architecture was to be modular and extensible, and that's something that is very important. What Neutron doesn't do for you is doesn't force you into a specific network implementation. What Neutron gives you an abstraction layer that you can use so that your compute layer gets some form of connectivity. And then the backend implementation of this network can be anything of your choice. That's the modular plugin architecture Neutron brings. That's where I think there's a lot of confusion. Some people say, oh, Neutron is my network feature and functionality. In reality, Neutron can be extremely thin. If you leverage one of the vendors, it's kind of a very thin abstraction layer that just passes through a API call from the OpenStack API layer down into whatever implementation of the network you have underneath. Okay, so this is kind of what these three slides talk about, and we'll share the slides so you guys can go through all of it. You're just going to take an API call that says create network, and you're just going to pass it over to the SDN controller and say, hey, create a network, create me, a subnet, create me these, router, create this interface between the subnet and this router, and so on and so forth. And again, this is where kind of the confusion comes in. Now, if you look at the architecture, a very ugly picture that I created, but what is important here is that when you look at the plugin, there is kind of a core set of feature and functionalities that come with the plugin itself that every vendor has to satisfy. So when you write a plugin for Neutron, you have to be able to create networks and create interfaces and all sorts of things. But the beauty of it is that you can also expose some additional functionality through extensions, and those kind of get automatically flagged and exposed through the OpenStack API layer. Again, enabling for differentiation of services and more advanced functionality to be built on top of it. Something that is happening, and I just wanted to mention it, there is a lot of conversations happening, especially the last summit, around advanced services. So this is something that today, for the most part, is part of Neutron. And some of the services are now becoming independent projects, with understanding that there has to be a better architecture for managing the integration and insertion of things like firewalls or load balancers or VPN devices and so on and so forth. But today, some of those advanced services are implemented in what is called a network node. So I'll show you a picture of that. Let me jump ahead. So the idea is that for specific implementations, let's say you have a very basic Neutron implementation, the feature and functionality can be implemented as agents. Now, map it back to the slide that I had showed you a while back, where I was showing you kernel space and user space. Those agents are nothing but VMs or user space components that can run either within your compute layer or more commonly in what is called a network node. So the way Neutron was deployed, especially at the beginning, was that you would have a few controllers that were running the overall OpenStack infrastructure, and then you would dedicate 1 or 2 or 3 servers as network nodes. And those network nodes were running layer 2, the DSCP, layer 3, firewall, load balancing, and so on and so forth on these servers, these dedicated servers. Now, there's quite a bit of changes happening in Neutron. If you're following what happened with Juno, some of those services are now becoming distributed and now becoming highly available. And so you'll see a mixed bag of some of those things being centralized, some of those things being distributed within the compute layer. The reason why it's important, getting back to your evaluation of the OpenStack networking solution and what you need to look for when you select a vendor or a basic open source components that are out there, is what type of applications do I need, and do I need to be able to scale out all my network services because I have a very large deployment, or can I go by and survive with a network node kind of implementation? So this is showing when you use network nodes, you have some servers that are dedicated to running layer 3 services or firewall services or load balancing. And so what that means is that every time a VM needs to access those services, traffic will be running over to those network nodes. This works perfectly fine for small deployments, works perfectly fine for deployments where performance is not an issue, but this is certainly a question mark for you to answer when you look at, am I growing my environment? Do I need to now start worrying about placement of that network node, because that becomes a potential bottleneck? Do I need to scale it up and size it such that it can satisfy the requirement of my growing environment? And so this shows you that the traffic handling can vary depending on the different services. So some of it can be local within the hypervisor, where maybe some of the layer 2 functionality are distributed and available within the kernel layer, and some of the more advanced services are instead implemented in the network node. So again, important to keep in mind when you select a solution versus another. So I just want to spend 10 minutes on what PLUMgrid does and show you how we fit into OpenStack and how we change some of those kind of architectural constraints there. So I already told you these, but just to graphically show you where we fit in the kind of cloud stack, we are a pure virtual network infrastructure layer, so we are purely software. We don't manipulate anything at the physical network layer. So we're just a software product that gives you on-demand virtual network infrastructure for OpenStack. We bring a differentiated concept of virtual domains, which we covered in detail earlier on. But the idea is that we have your physical network infrastructure, we deploy on top of it as an overlay solution. We give you the ability to create virtual domains, so this isolated multi-tenant environment. You can select from the PLUMgrid portfolio of virtual network functions, and you can create as many of those virtual domains as you need for your environment. And we are fully integrated with all the major distributions out there. Some of them it's completely automated, some of them it's a manual install, but you can choose to select any of those OpenStack deployments, and we make sure that you can leverage PLUMgrid within those. So there's kind of three pillars of the PLUMgrid architecture. The first one is that it's intrinsically scalable because we built everything to be fully distributed. So all the network functions and services that we provide all reside within the hypervisor layer and are fully distributed and are created on demand depending on which compute nodes need to access switching or routing or security policies or NAT functionality. And I'll show you in the next picture in terms of a physical deployment what it looks like and where these features get inserted. The other component that is important, back to the high availability considerations I was making earlier on, we designed the architecture such that even if the control plane was to completely die, so if the controller was to completely die for some reason or get completely disconnected from your infrastructure, you will still be able to continue forwarding traffic between VMs. Again, this is based on the fact that all the features are implemented in the kernel. We never have to send packets out. And the last bullet functions from third parties that can be open source or commercial inside a PLUMgrid virtual domain. So these purple icons are all PLUMgrid. The orange icons are from partners. So we've done integration with things like Palo Alto Networks to Quagga and Bayada, and we enable you to integrate these components within a PLUMgrid virtual domain. Why is that interesting? Well, there's a lot of use cases out there. One example is you're an enterprise customer, you have many investment, you have services already deployed, and you want to make sure that you can now leverage them in a cloud environment. Back to your question about peering virtual domains, you want to have specific routing stack that you want to leverage when you peer virtual domains or provide features to your tenants. You can do so by selecting, for example, Quagga or Bayada as a component as part of the PLUMgrid virtual domain. So the service insertion architecture is something that is very unique to PLUMgrid, and it's a very long conversation as well, so I don't want to necessarily cover it in details, but if anybody's interested, we can certainly take it offline and talk a little more about it. Now, in terms of where things reside, there's kind of three components that we deploy. There is a component that we call the iOvisor that sits within the compute layer. There's the same component, the iOvisor, that is leveraged as a gateway, so to exit from the overlay infrastructure into the legacy infrastructure. And as I said earlier, this can also be something from a partner like Arista as an example. And then we have the PLUMgrid directors. So the directors are purely control plane functionality, kind of the brain of the system, the one that talks with OpenStack and gets the definition of the virtual domains, and based on where everything needs to be connected, makes the magic happen, establishes all the overlay tunnels that are needed for communication between compute nodes. Now, I have one slide which we really like. It kind of shows you where these virtual domains there. So you're a user, you log into OpenStack, you create your virtual domain, your dependent network. What really happens under the covers is that PLUMgrid is integrated also with compute layer in OpenStack with Nova. We have what's called a Nova base driver. So we are aware of the fact that interfaces come up, and we are aware of the identity of these interfaces. So whenever a VM comes up, we capture that event, and we look up kind of the information of the VM. We say, oh, okay, we have VM XYZ, it belongs to Josh, and Josh has created this virtual domain blue. And so based on that VM comes up, in this example, in those two servers there, what the system does, it will automatically kind of distribute the entire virtual domain topology down into the kernel. This is, if you have to remember one thing, this is the thing that we do completely different from anybody else. So we let you completely distribute the entire network infrastructure within the kernel. It gives you kind of advanced level of performance and scalability that you can get out there. And it's all event driven. So only when the ends come up, we populate the network infrastructure within the kernel layer. I'm going to pause for a second because this is where usually people ask or have comments. Yes. So the IOvisor is it's a kernel module that would fit exactly where OBS sits. Think about OBS as a hard-coded data plane that was designed for open flow kind of use cases and was designed to satisfy switching and basic kind of routing functionality. The way IOvisor was designed, IOvisor at the beginning of time is like an empty box. It doesn't have anything in there. And based on what you define in the virtual domain, the IOvisor becomes a switch, or becomes a switch router switch, or a switch router NAS security policy. So what is fundamentally different is that instead of being hard-coded and predefined, the IOvisor is a runtime programmable environment that gives you the ability to load dynamically all the network functions you define as part of the virtual domain. But conceptually, it fits exactly within the kernel, exactly as OBS says. What is different is it doesn't have a user space component, doesn't have the user space component that OBS has. It's not flow-based, so we never hunt packets up to user space to look up a new flow. So it's fundamentally different from an architectural perspective, but from an insertion point, it fits exactly within the kernel.
When you say within the kernel, you don't.
Yes.
The portion of OBS. Switching element. So it's a modern version of OBS also designed for other data options. So OBS itself will limit support and support people. And that is
yes. That's why I said that we do not have the user space component that OBS has. And we do not have it for a variety of reasons. One is, again, because architecturally we're not flow-based. So the reason why OBS has a user space component is because when a packet comes in, it's going to hit the table to sit in the data path. And if there's an entry for that flow, the flow is going to be processed directly in the kernel space. If there's no entry, it's going to be spun up to user space where it gets looped up. And potentially even spun up further to the controller. And that's why there's a user space component in OBS. From our side, the way it works is that this sits exactly in the kernel, replacing the kernel module that OBS is. And there is no need to send packets to user space components. The NSB intelligence, the overlay intelligence, the family intelligence, all those things that get communicated down to OBS through OBS PD and all the communication protocols here happen between the IOvisor and the director cluster. Make sense? Any other questions? In every compute node, yes.
There was a repeat question.
Yeah, so the first here was asking if there's an IOvisor in every compute node, and the answer is yes. So when you deploy OpenStack, let's say there's Mirantis gentleman in the room, when you set up OpenStack with Mirantis, you're going to get all the compute components up, you're going to get your source component, and as part of that information, you can get PLUMgrid up, and by getting PLUMgrid up, what happens is you're going to get the iAdvisor deployed in every compute node that you have there. And so once you start defining your network in OpenStack, OpenStack kind of makes it hide what the backend is, right? So you're going to just plug into the UI and start creating networks. And what will happen in the backend is that this network definition will get to the director, and then the director will tell the iAdvisors what to implement based on where the VMs are. So the question is, if the iAdvisor is SDN compliant, what does that question mean? So the question is, if you're OpenFlow compliant, we do not leverage OpenFlow. So OpenFlow would be an application that gets built on top of our platform, but because we do not leverage OpenFlow as a communication protocol, we don't need that to be like.
In general, if I may add something to that, what this architecture tries to get away from is what's called flow-based architecture. So basically, the idea that a data plane is just a sequence of matched actions like a switch. Our data plane is more complex than that. It can be turned into a switch, a router, a load balancer, a firewall. We're able to render any network function directly in the kernel. We can build the entire topology directly in the kernel. So we're not a switch. We pretty much become more the kernel into any networking appliance and into a series of networking appliances. So we can render as that picture shows. We can run in the entire network. So the packet comes out of the virtual machine and it will go directly to the switch router and firewall without leaving the computer. And when it exits a complete node, it's already been processed through the time. So what we try to get away from is the fact that the network is a series of flows. We believe that the network is a series of objects, and those objects can be programmed to do whatever you want to do. If you think about how SDN is changing lately, we're changing from the idea that a network is a series of flows to consider that a series of objects. So the protocols that are being developed just now, Outflows from Cisco and other protocols, instead of telling a data plane, hey, whatever comes from this port, send it to this other port, but the same is, hey, I want to switch, I want to route it, I want to load balance. So that the underlying implementation will create that object however they want to create it. What that allows you to do is create a stateful network, full network in the data plane instead of moving the state up to the control.
Communication between these objects, does it now become like one function of code, like you think of software, software it is?
I mean, it's still SDN in the sense that you're separating control plane and data plane. But the misconception that the early SDN approaches had was that SDN is something where you inject directly a flow into a data path. SDN is separating control plane from data plane, making control plane programmable, right? But that data plane doesn't have to be a switch. If you think about the first version we were discussing with this, the first OBS is a simple switch. What happens when you have a simple switch is when you want to do something goes with switching, firewalling, routing, whatever, you need to go to a network node that has a switch and a balance. So traffic goes to the network node and back, and up to the network node and back, and you get this terrible garbage. Now, the new version of the switch is with routing now. So we have this single switch, this single routing. If you want to do that, you still need to go to the network node and back. You want to do stateful firewalling, you still need to do that. So newer approaches relate to the fact that instead of adding different types of flows to the data plane, you should probably program objects in there. And those objects should be programmable so you can create any sort of object in the data plane. And it's kind of like people, instead of being an imperative model where you tell the data plane entry point to exit point, it's what is called a declarative model. You tell the data plane, I want this object or whatever. So was that a question?
You do it that way.
So I assume since we're moving everything down to the hypervisor level, the compute nodes need to be directly attached to an external network to access provider networks. We no longer have to do that in a central place.
So there's multiple layers to this question and answer. So first of all, yes, so we move everything within the hypervisor. So a lot of the feature and functionality will be implemented within that layer. And NAT, for example, will have one direction of NAT being implemented within the hypervisor layer. Remember, there's always the gateway. So the gateway is really the component that we leverage to exit from this overlay infrastructure out into the legacy network. And this gateway doesn't mean that it's a single device. It can be a cluster of gateways. So again, another layer where we distribute. And that's where, for example, the reverse direction of NAT hits. It's where you have, again, another layer of distributed NAT handling the inbound flows and understanding, okay, this packet is coming in with this IP, and it has to get to the destination compute node, which sits, somewhere in my cloud infrastructure, and I'm going to use the overlay network to get to that environment. And then, based on the implementation of NAT, I know that I have a VM, so I need to do some form of translation to get it to that final destination. So NAT really, in the PLUMgrid implementation, what Fernando was referring to, it's fully distributed, and we kind of have this topology, what we call rendered, meaning the topology is available both in the compute layer as well as the gateway. And the gateway is really the one that is physically attached to the external network.
Do you have a TCP gateway? Another example, another way to look at this architecture, for those of you that are coming from a networking background and that are used to deal with distributed switches on routers, your classic chassis, right? You have control modules, you have line cards, right? In one of these. Well, another way to look at this architecture would be your directors, your brains are kind of the supervisor, the control module. That's where your protocols run, your PGPs, MSDFs, packets, and then you have kind of line cards in your server. So your server is processing the traffic. The traffic is not hitting the control plane. The traffic is going from IO-visor to IO-visor, from IO-visor to external world. So that entire thing, that entire picture is kind of like your distributed system. If you want to connect to an external router, you would connect it to the gateway. So the inside of the data center, existing switches, routers, whatever Cisco, Juniper, Broadcast, Aristas, that are actually your backplane now. It's transport. For us, it's transport. It's internal support. We don't really care what you're running. Now, if you want to connect to a different cloud, normally you would connect to it, and that gateway can take you directly to another OpenStack cluster. We can take you to your MPLS-PE and get you into a VPN, or it can get you to your Ironic physical servers, when your terminal servers controlling Ironic. Your real world side of OpenStack is connected to the gateway. And inside the gateway, what you have is this virtual switch, virtual router that connects VMs.
And just, to add something to the NAT or gateway question, what is important about leveraging, for example, virtual domains is that you have a much better consumption of IPs, a much lower consumption of IPs, because you don't need to have a real IP per compute node. You can have, one IP per virtual domain if you need that, and then that kind of gets maxed through the overlay implementation. So, long conversation again, but better utilization of IPs than NAT break. NAT is actually one of the features that a lot of our customers are using us for. Like, if there's one feature that I could name, it's certainly distributed NAT. A lot of interesting use cases you can do once you have distributed NAT.
With an architecture like this, obviously the gateway provides function egress, but what about intra or inter-tenant monitoring and tapping?
So if tenants need to communicate with each other, it depends what the design you have. If you go through kind of what we call a service virtual domain, a service virtual domain is nothing but a logical construct. So what you would literally do is you would go on the UI or through OpenStack or whatever you want to build it, and you would just create two virtual domains, and you would create a third virtual domain on top and interconnect them. And I can show you a picture as well. Now, what that means is that inside your compute node, you will have the representation of the two tenant virtual domains as well as the service virtual domain. So inter-tenant communication doesn't necessarily have to go through a gateway or through any air-pinning network node or any component there. Everything stays within the hypervisor layer if the VMs are sitting within the same server.
How do I audit that?
How do I
audit that? Like, monitor
So there's also things that we built into this product, from real-time analytics to the ability to tap into any VM and kind of look at the real-time traffic coming out of that VM, the ability to trace packets through a vehicle domain, and so on and so forth. So there is a very powerful set of operational tools that we have built as part of the product to help you. I think this is how you operate it, especially when you have a physical and a vehicle layer. It's fundamental.
Yeah, just add very quickly, the other thing we're looking at is a virtual task as well, so that you can actually have their standpoint. That was looking for.
I have a follow-up question. You pointed out how your solution is different from open basic, and I understand that. So you put more knowledge, in effect, topological knowledge of each of these distributed kernel modules of each compute node. How do you deal with the potential explosion of information and the exchange among the compute nodes for a very complex technology at scales?
Yeah, so very good question. So a couple of answers to this. So first of all, a lot of the intelligence of this system is stored in the control plane infrastructure. So something that PLUMgrid did, we custom built all the control plane components for large-scale cloud solutions. There is obviously uses for generic off-the-shelf components, but we felt exactly for the reason you're bringing up that there is a need for very robust infrastructure to be able to store information in a distributed, resilient way. So all of the algorithms and technology that we run at the control plane level that enables us to run a distributed cluster with 3 nodes where one can fail and all the information remains in the system and so forth. That's a very big, important part of our solution. Now, at the data plane level, the way things work is what I was mentioning earlier. So everything in the system, in the PLUMgrid system, is event-driven. This is fundamental. What this means is that at the beginning of time, there is nothing pushed into the compute layer. Everything is empty, everything is brand new and fresh, like blank slate. Every time VMs come up, based on the events, we populate the necessary information down. What this means is that we might have how many? 20 VMs, 30 VMs, 15 VMs, whatever the number is per compute node. That's the amount of information that we push down into the kernel. And the actual implementation of this topology, what we call PLUMlets, are extremely efficient in terms of consumption of resources within the kernel layer. And so we don't just bluntly populate everything you need out there. Only everything that is relevant to that specific local node is pushed down. And again, back to Fernando's analogy of the line card, it's exactly how it works there. We only have the information that is needed to then look up a destination and send it over the backplane of your distributed chassis and send it to the destination line card. So we're very efficient in terms of what type of information we push down into the kernel itself. That's very important, yeah. Any other questions? Yes?
IPv6 support for components?
Yeah, we do not currently support IPv6. In the roadmap, something that a lot of our customers are obviously asking us about, but that's not something that we are currently supporting. So we can take more questions. I just wanted to give a chance to Fernando to share it. Why don't we take a couple more questions, just a couple of minutes, then we'll give it to Josh. I think we talked about all of this, things distributed, blah, blah, blah. So let me, or you can even just.
Yeah, I'll stay here. We have very little time, so in order to make sure that I don't go over my time, I'm actually going to play a CAN demo. So this is actually a recorded video, but I have the demo running on the laptop. If you guys want to see that, I'll be happy to show that to you. What you can see on the right side is the PLUMgrid platform. And again, this is what runs under the hood. So on the left side, you're going to see an OpenStack, a standard OpenStack window. So when in OpenStack you tell Neutron, hey, I want a network, or I want a router, or I want whatever, then the PLUMgrid platform creates that dynamically during the load script. But,
Sorry.
No problem. So what you see here is a Python script calling Keystone, Neutron, and Nova. This is going to create networks here, and this is dynamically going to create also a tenant in PLUMgrid that is going to create all the networks that you guys are seeing popping up here automatically are going to be created dynamically in the PLUMgrid platform. So this is the way that you guys are consuming networks today. If you're running PLUMgrid, you're running OpenStack. This is what is going on under the hood. So as you guys can see, this script is creating a full set of networks and tenants, and anything that Neutron understands is being created dynamically in the PLUMgrid platform. That means that all these networks, all these network elements are going to be rendered dynamically into the kernel of the compute nodes that have any virtual machine in this topology. And the other thing that we did is what most people call NFV, Network Functions Recall section. So once we have created the networks and the routers that OpenStack knows about, we want to create routers, firewalls, VPN terminators, and balancers that are running on virtual machines. So in this case, we're going to create virtual machines that are running IATA, local liberty, and we automatically configure them on the fly from vanilla images. We're able to configure everything in those VMs. So the IP addresses, the security rules, the names, everything. So we create an underlying infrastructure of PLUMgrid components, and then on top of that, as you guys are seeing here, we're start creating VMs that are hosting, routers, firewalls, balancers, and everything that we want to create. What you guys see here is a connector. This is something that is not existing in OpenStack. As you guys can see, I remember someone was asking, how do we interconnect tenants? Or how do you interconnect tenants in OpenStack? Tenants in OpenStack are not supposed to be connected. You need to connect them through shared networks or through external networks. But our platform does many more things that OpenStack Neutron does not know about. This is one of the things our platform can do. Just connect to tenants, transfer it. So make a network go between the tenants, and we're doing next year. So what you guys are seeing here is the script creating a VM dynamically. As you guys see, this is a IATA VM. If someone is familiar with BIOS, we're putting up a IATA VM, configuring that on the fly, so that when the router comes up, it's already configured with router name, with the IP addressing, with these two routers are actually running the RRP. So this is just to show you guys how, first, PLUMgrid implements everything that OpenStack knows about. It also implements some other features that we do have in our platform that OpenStack is not supporting today. And also in the network functions virtualization environment, we can use OpenStack, okay, virtual machines running other networking functions, third parties, right? We could be running F5 load balancers, BlackBerry load balancers, checkpoint firewalls, Palo Alto firewalls. And we can create them on the fly, configure them on the fly, and they pop up automatically. Okay? So this is a classic use case where these topologies are, for example, for they want to run underlying router in a switching infrastructure. On top of that, they want to go their Cisco's, Juniper's, Ericsson's, and run virtualized versions of the devices that they run in hardware. Okay? So this is basically what the demo is about, creating underlying infrastructure that OpenStack knows about, and creating on top of that virtual machines that are coming already configured with that. Again, we have that running on the net. Again, we can configure that on the fly if any of you want to see the real demo instead of this quick recorded video. We're already going.
We over time.
We're already going well over time. But if any of you is interested in NFD and virtualization, or wants to see how we actually under the hood implement the distributed fashion what OpenStack does, what the Neutron API knows about, it's being made available. Any questions on this or any questions? I think we've stolen enough of your time.
Until 10.
Is that?
Wait until 10 o'clock.
Okay. All right. Thank you.
All right, so I hope this session was helpful for you. I know we went very deep, very quick. Some of you had some very good observations. We'll be around, so happy to discuss more. I'm very passionate technologist, as you could have seen probably, but so I'm happy to chat more with all of you. Sure.
Some of your customers, what are some real true-to-life experiences that you've had?
Yeah. So that's a very good question. Again, I'll try to keep it short because in the sake of not stealing too much time from Josh's presentation. But we work with a variety of customers that have different use cases. A good example for us is those that are building public cloud solutions. So large hosting providers, cloud providers are now trying to offer services on demand. The power of what PLUMgrid does is that we enable them to create and offer this very rich multi-tenant environment on demand. When Josh goes through the presentation, what we do with some of our customers are building platform as a service kind of offerings. And what we can do is we can very easily configure the virtual domains to match the requirements of Cloud Foundry. So Cloud Foundry has some very specific requirements in terms of some components need to talk to each other.
And also, don't forget to cast your vote for the board of directors for the OpenStack Foundation, which is this deadline is this Friday, if you got the email. Also, the third thing, the presentations will be uploaded and shared with everyone. Does everyone want a bio break, 5-minute break? Stretch your legs, stand up, drink some water. All right. Keep it to 5 minutes, though.
Josh, do you want to be on the WebEx?
Yeah.
Good job.
You don't actually really want to talk to us recruiters, though. You want to talk to them. This will be easier to get through. I'm not nearly as smart as folks in PLUMgrid, so this will be very easy to follow along with. Does anyone know who I am? Okay, have to. I should probably intro myself, but I'll skip that. I'll just get to the story. Tell the story. This is a fun. We put this on a T-shirt for VMworld 2012, which was really confusing at the time because VMware was not yet a member of OpenStack. And I was the CEO of a company called Piston, selling OpenStack. And I had a partnership with VMware, selling a competitive product. And I won Best of VMworld for a product that competed most directly with their sort of golden egg. Well, too bad. I'm not going to spend my time fixing IT problems. Years doing that. As have, I'm sure, all of you. This T-shirt was so confusing, and the fact that we won VMworld was so confusing that Michael Dell showed up in my booth about 5 minutes later come and find out what the hell was going on. So this, to me, was sort of the beginning of the Cloud Foundry being truly interesting before it was a product or it had a community at all. How many of you know what Cloud Foundry is? Okay. The same people who know who I am, which, all right. I was the technical lead for Netscape many, many years ago, and program manager at AOL when I worked on was this guy named Bob Parsley, and he had this sign on his door. And I've worked with a lot of people who think they know what Agile is, and some of the folks who define the term for years and years, but I think this is the definition of Agile that is interesting. The purpose of software is to exist, and it is better to ship than not ship. And the meta-narrative of cloud, for as long as I've been doing it, which is more than a decade now, it seems ridiculous, is always about going fast and sort of figuring things out when you go. And every time we have a new layer in the cloud pizza, the story is always that this layer will help you go fast. And it turns out those other layers didn't, even though we told you they would. But for real this time, Cloud Foundry actually makes you go faster. So yeah, as I was pointing out, I was one of the co-founders of OpenStack. I led a team at NASA that built this thing called Nova a long time ago. This was my blog post when we launched it. Before it was called OpenStack, we didn't have a partnership with Rackspace yet. It was just a thing that we did in 17 days. So for me, cloud has always been about going fast. And PLUMgrid made a very eloquent argument of why NovaNet is such crap. It doesn't really do any of these things. It's not really extensible. It is an embarrassing piece of garbage that I wrote in a day and a half, and which is still used in 70% of all OpenStack deployments around the world. So the migrate off of NovaNet problem is a giant problem that I have to personally apologize for. Which I do on a very regular basis. I flew to Korea recently, and I met with one of the largest companies in Korea. We've been using OpenStack since Diablo. How do we get off NovaNet? I promised to come talk about Cloud Foundry, mostly because my current employer, new employer, Pivotal, who I'm very happy to be employed by, paid for the beer that you're drinking. And they do sell Cloud Foundry. But also, when I was recruited and hired at NASA, they hired me to build a PaaS. That was the mandate, that was the job. And I worked on it for about 6 months and got extremely fed up because there was no IaaS layer for us to use. We were not allowed to use Amazon. I was trying to do it on top of VMware Workstation originally and then vSphere, and I sort of threw my hands up in disgust and said, there's no public APIs on any of this garbage. It's impossible. I will have to fix IaaS first. So we spent 17 days. Actually, then we spent a year trying to run Linux, which is sort of the chapter we skipped over. Then we spent 17 days writing OpenStack, and then I spent the last 5 years trying to clean up that mess. But I had finally come back to working on PaaS, which was the point of the whole exercise. So those of you who are just getting up to speed now think OpenStack is really cool. OpenStack was built for one purpose, which was to run Cloud Foundry. So I think Cloud Foundry is pretty cool. Now, it turns out it can do all sorts of other stuff, which is nice. A little caveat here, we used to have a joke in the OpenStack community in the early days that OpenStack was free as in speech, love, and beer. Which I thought was actually the wrong message because it made everybody think that they didn't need to pay vendors for OpenStack, and then they got themselves into terrible messes trying to use Trump. Generally, I think it's a good idea to have a vendor when you're using open source. And so I wanted to caveat that this is free software as in speech, not free software as in beer, like the free beer you're drinking. Has everyone seen this diagram? Pizza diagram of cloud, right? So we talk about infrastructure services being, you still have to provide your own dining table and oven and fire, but they give you the dough. And then platform as a service being, you need somewhere to sit, and you probably need your own beer. You should say beer there. But everything else is dealt with. It's delivery pizza. This was just in case. All right, we're talking about Cloud Foundry. You can tell it's a really important project because it has a great logo. all great open source projects have great logos, just like all great programmers have great peers. The world's leading open source platform as a service. I will come back to this trend of its leading. I had a really fun time in 2010 and 2011. I got to go out on the stump and talk about how OpenStack had won. And people were like, what is OpenStack? What are you talking about? It seems like it's 12 people at NASA, 40 people at Rackspace, and we're entirely. It turns out I was right, so now I get to do the same thing about Cloud Foundry and say, look, Cloud Foundry has won. We're going, what are you talking about? That doesn't seem like the fight's over yet. No, the war is over. I waited slightly longer this time. It's been obvious to lots of people for about a year. There are some things about Cloud Foundry I think are really interesting. On the technical side, I have no architecture diagrams at all. In this presentation, I don't really want to talk about how Cloud Foundry is architected. I wanted to talk about the communities because I think it's more interesting because I'm treating this as a recruiting event. Except instead of hiring you, I'm recruiting you all to work for me for free. This is what open source is about. In fact, I believe all open source in the world is designed for people to work for me specifically for free. I would say it was the winner. I think what's interesting about this diagram, which is, we just spun up the Cloud Foundry Foundation, and we're trying to skip all the mistakes we made with the OpenStack Foundation and do things kind of always better, right? What Toyota would call continuous improvement. What's interesting is how many of these folks are the same players as the OpenStack ecosystem. I haven't thought about. Lots of people. There's also more SIs and more customers in the early part of Cloud Foundry than there were in the early part of OpenStack. But the feeling is very much the same. Lots of people have come together trying to solve a problem that feels too hard for any one of them to do on their own. But as a group, it seems manageable, and the solution has more value if we all buy in on one solution as opposed to 6 different ones. So I think of you guys as stackers. How many of you have heard of OpenStack? I've been asking that question for years and still haven't asked. So I wanted to talk about how Cloud Foundry is the same as OpenStack and how is it different, how you could get involved, why you would want to get involved, and then what I want you all to do. If you wanted me to talk about technically what Cloud Foundry is or how it works, instead, I also have that deck, but I really don't want to feel like this is a pitch. So if you start asking questions, I'll give answers, but otherwise I'm going to go through the material step. And probably tell jokes. At this point, I don't even want to talk about this slide because I have a hard time imagining a meaningful open source community that didn't have these 3 ingredients. If it's not Apache 2 licensed, you can't get commercial participants involved because they have no hope of building a business. I mean, really, that's the general consensus with most people working in open source right now is it's really hard to build a sustainable business on a GPO. May be doable in the outside case, but Apache 2 is so much easier, there's really no reason not to. If you don't have vendors and users and developers involved in your community, if you're missing any one of those 3, it might be interesting for a little while, but it's probably not interesting in the long term. And API first, it's kind of all microservices and form factor. You guys heard of all of this, right? Like the new, better way to build cloud-ready apps. If you're building a cloud platform and you're not building it as if it was a cloud application, you're probably doing it wrong. This stuff, I mean, we stole this from Amazon in 2008. Shared ecosystem, I pointed this out earlier, but some of the biggest vendors, in fact, most of the biggest vendors of OpenStack are also Cloud Foundry vendors and participants. There are a few others that are notably on their way to the slide. I've been predicting that Red Hat will join Cloud Foundry for 2 years, I think, 2.5 years. The $10 bet open that they will join by the end of the year. I lost that bet last year. I'm usually 18 months early. I had the same bet about VMware joining OpenStack, but I made money on that bet. I plan on making money on Red Hat, but if anyone wants to take those odds, that'd be fun. All right, there are a bunch of things that are different. Some of these things matter, some of them don't. Some of them will matter to you and not to other people, but let's go over them. The languages are different. right? OpenStack is in Python because I thought Python was a good language for NASA. Not for any other reason. Not that Python is magically a great language, although I like it, but because NASA had a lot of Python people, and because Python's good fit for scientific computing, and that was what we were happy to work with. And language really defines programmer culture in a really interesting way. And it's very permanent, and it's largely invisible to media and marketing. Well, language is one very good thing. See? Mostly? So, Foundry was originally mostly Ruby, and then a lot of it has been rewritten in Go. And progressively, probably the whole thing will be rewritten in Go over the next year. I don't know why, but what's nice about both of those languages, and certainly how they're implemented in Cloud Foundry, is they actually do test-driven development, meaning they actually write the test first, as opposed to what we do in OpenStack, which is we pretend to do test-driven development, and we write the code, and then we write tests, and then we commit both together, which looks a lot like test-driven development. The release cycle is an amazingly important difference. I promised I would read. Actually, I think I was very particular about a goal not to read. But the 6-month release cycle of OpenStack is one of the only initial decisions for governance that I have never been happy about. I think it has been bad for the community. I think it continues to be bad for the community. Mostly because we actually don't make the components work together at that 6-month date. How many of you ever ran Java? Remember that? We did. Yeah, that was not fun. So in Cloud Foundry, we don't pretend. So look, the vendors are actually going to take ownership of making the various bits work well together. They're going to do the CI, they're going to do the certification, they're going to do the long-term support. So having a community pretend to do that and then not do it is only going to produce pain. So let's not. So every component in Cloud Foundry has a release roughly every 2 weeks, whenever they feel like it. Different projects, same as OpenStack. But they don't pretend to snapshot at some point in time. The vendors do that. So Pivotal does it roughly once a quarter. IBM does it, I don't know, they feel like it. Staccato did it once, as far as I can tell, some years back. They probably won't do it again. So the release cycle is much more about the vendors of the platform. And then we have customers and users who are using right off the trunk, same as OpenStack, but they know they're doing that. They know it's dangerous. They're not on essentially a snapshot in time trunk release that they're pretending is actually a stable, named some lettered acronym. That's different. OpenStack has a foundation that we created. Looking back on it, that was the right call for where we were and people we were trying to get involved. I don't think we got the governance model exactly right. Certainly in DC we didn't, because the goal of that whole exercise was to make sure that NASA could be a member. NASA has never been a member. We didn't get the bylaws right. No other government agency has ever joined, so it didn't work, but it was the right goal. But Foundry hasn't tried. We are trying to engage more in federal government, but yeah, is that a question or a yawn? Okay. So rather than go through all of the expansion work of drafting up an entirely new organization, we are a Linux Foundation subproject, which I think works really well. A lot of the burden of running an organization is already on them. They do a good job. And we still have our own governance process. We have our own team structure, review process, commit process, joining board teams, etc. Those are roughly different, but parallel to some OpenStack activities. Installation. I think that was one of the other really painful things in the OpenStack world is we didn't have install tools when we started. Again, that's totally my fault. We were using Puppet scripts when we launched OpenStack, but we weren't allowed to release them because they had NASA IP addresses in them. So we launched without them, and then we got talked into converting to Chef because the Chef guys were really nice to us right after we launched OpenStack. We didn't release those recipes either. And then the community went off and built like Puppet and Chef and Bash recipes. I think you can call Bash a recipe, which is DevStack, which was mostly about making it super easy to demo, but not what anyone actually used. And then Piston built Oxy, and Marantis built Fuel, and Dell built Crowbar, and every single vendor built a different installer package. And then we all pretended to rally around Ironic, which doesn't work. So we didn't do that with Cloud Foundry. Trunk uses Bosch. Bosch is amazing. Use Bosch. Canonical also uses Juju. Juju is actually pretty cool. And there's a whole bunch of other services you can install with Juju. So you're basically Bosch or Juju in Cloud Foundry. If you do something else, you're just being perverse. There are a couple of perverse people using shit. Pivotal doesn't use IRC. And this is really because they actually pair program, which means none of the developers inside Pivotal are ever doing anything other than coding. They don't have email open, and they certainly don't have an IRC file. So you can't get them on IRC. But all of the product managers are on email, and they are on the mailing list every 20 minutes answering questions from the user about how to do this, that, or the other thing. So the communication is nearly as good, but it's just a different tool. If you're used to IRC-driven open source, that doesn't work in Cloud Foundry. Get on the mailing list. Source code and review, also different. They both have CLAs. You got to go sign them, individual CLA as well as corporate CLA. It's not that hard. People have been doing this for forever. OpenStack uses Git plus Garrett. Garrett review process, if you've ever been through it, is complicated, but it does work. You've got to learn it. Cloud Foundry just uses GitHub and pull requests. Work the repo and submit a PR. If you want to get a lot of PRs accepted, it is much, much easier to do if you engage really directly with the Cloud Foundry community. And that's one of the things that's very different in the governance model. So in OpenStack, our goal was to get everybody in the world contributing, right? As big a membership as possible, as low a barrier to new contributors as possible. Submit a one-line patch. Awesome. Good job. You get a badge, we send you a t-shirt. Cloud Foundry is the opposite. They're like, please, we do not want hundreds of thousands of developers. He's 5 years old. It's actually pretty stable. And everybody working on CF so far is full-time on CF. Not full-time developers, full-time Cloud Foundry developers, whether they're at Pivotal or not. So that is the bar. In order to be a core team member in the Cloud Foundry community, you have to demonstrate that you're full-time on Cloud Foundry, which is a much higher bar than most open source projects. But it's really effective because the sense of ownership around the code is much, much higher than it has been in a lot of other organizations. There's an encouragement to use what's called the Dojo process, which is literally come to San Francisco or Palo Alto, sit with the core CF teams, pair program with them for 6 to 8 weeks. 6 to 8 weeks worth of code on a core, and then you can be committed. Go anywhere in the world. We know that you know the code base. We know that you passed the basics of like it's actually test-driven code. IBM went through that process. A bunch of other ecosystem members have gone through that process. So it works. And yeah, we're creating a lot of friction in terms of developer engagement, but we've actually made it a lot easier for users to engage. So I think this is one of these trade-offs where balance is probably pretty good. And on the adoption side, the side effect of that is most people using Cloud Foundry are running their product in production. Whereas years into OpenStack, most people were still running Trunk, supported by professional services for dev and test. So it makes it easier for other users to talk to new users and say, yeah, we've been using that for years. This is what we did with it. Alongside, I was going to use it to feed the world. Maybe. I don't want to bring this up. Cloud Foundry is not a competitor to OpenStack. I think this was the point of the slide, right? There's been a ton of confusion. I was on the OpenStack board since we started OpenStack up until October when I stepped down. And I'm really happy to not be on the board anymore. It's taking like 10 to 20 hours a week of my life for 5 years. But we ran a process for the OpenStack Foundation called DevCore, which many of you may have heard of. Rob Hirschfeld and I were the chairs of the DevCore meeting. That was the definition of core. How do you decide what has to be in every OpenStack? Every public OpenStack cloud, every private OpenStack software. And the reason we had to run such a complicated process came out of how we started OpenStack and the fact that we had some confusion around the words we were going to use in the mission statement. And I wanted to say infrastructure as a service cloud, and We opted instead for cloud computing platform, which created this ambiguity of how big and how hard up the stack is OpenStack supposed to go. Really, the goal was OpenStack is about API extraction of resources, whether they're virtualized or not, compute, storage, and networking. And that's it. Because you can't have an opinion about how to orchestrate those resources or what their lifecycle management is, or even complex off scenarios around them and workflow without becoming prescriptive about the use case you're dictating. And we looked across public clouds and private clouds and academic clouds and government clouds and financial services clouds, and we couldn't find enough commonality for orchestration and workflow to say that should be part of OpenStack. It's not part of the 80/20. But in the spirit of having a very open ecosystem, we said, great, build 20 versions of orchestration for OpenStack, call them all OpenStack, stick them in the ecosystem, stick them in Stack Forge, and we'll figure it out. Which, if that had been, everyone was clear that that was ecosystem, that would have been fine. What happened was there was this endless drift to believe that everything that was called OpenStack was therefore going to be in every OpenStack cloud, and every OpenStack project, and every OpenStack product, appliance. And so folks kept going, well, why doesn't your cloud have heat? Because heat is not a general purpose solution to the problem you're trying to solve. It's a totally different model. So now we spend a whole bunch of time in the OpenStack community, in the Foundry community, the OpenShift community, but also saying, look, PaaS is over here, IaaS is over here, and there's orchestration possible that's sort of this gray area, but here's how these things are different. Just because they're containers doesn't mean they're PaaS or IaaS. Just because it's bare metal doesn't mean it's not one of those other two. It's just terminology. So this model of saying you want to go faster. You've got devs that want to go faster, and Intel, Catherine Spence, gives a great presentation saying we can go from idea to production in 1 day. This is about Foundry on OpenStack. Which is a crazy concept for a company that before they deployed Cloud Foundry, 6 months, and before they deployed OpenStack, it was more than 18. So they've gone like several orders of magnitude more productive on dev productivity. But dev productivity is all about day one. It's all about I wrote the app, I pushed the app, I went to the beach. And then there's all these operations and DevOps and maintenance people are left going, how did Heartbeat came out? How do we patch your app? What language did you use? What operating system is it using? I can't get into your VM. Oh my God, I'm just going to turn it off. We call that day two problems. And it turns out that helping organizations solve day two problems is a bigger business value than helping developers go faster in the first place. If you could just keep the app up, it's worth more than deploying it fast and then turning it off. I don't know. When you walk through it, it seems obvious, but at the time, it was amazingly revolutionary. So there's this big push with Cloud Foundry to solve day two problems, to be able to do what's called blue-green deploys. Push a new version of the app and then gradually roll traffic over to it without turning it over shop. That's easy. You can patch the operating system and then restage every application in the platform to take advantage of a new OS image without rebuilding every VM base image and re-snapshotting it.
Where's that reference come from?
So.
Blue-green?
Huh? Oh, blue-green deploys. Yeah. Blue path, green path. They always have blue line. I don't know why. Who picks these colors? I don't know why I put the slide in here. This feels like very process-oriented, but there's all this stuff. There's this debate about where HA happens. And I can't believe we're still having this debate. It's like 2015. We're still talking about HA and who's responsible for HA. Everybody is responsible for HA, same as security. Everybody is responsible for security. This is DC. You guys invented defense in depth. So CF has 4 levels of HA. That doesn't mean that your IaaS can be horribly happy. It also doesn't mean you should use just shitbox hardware. It's a good idea to, yeah, commodity is fine. Having your data center catch on fire, not fine. Turning your entire cloud off for 2 days, not fine. Are any of you using production? Not anymore, right? 48 hours of scheduled downtime, of which they used 40 hours of the entire cloud and every VM in it, all availabilities of all agents.
They have a really cool building.
They wrote some very nice emails about it ahead of time and end. Agent is important. I don't want to talk about this. Blah, 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 go fast. I was going to tell a story about Netscape, if I have just 1 minute. I just want to drill back this point that it's about going fast that really matters. So when I was a tech lead on Netscape, we were scheduled to have Walt Mossberg of the Wall Street Journal review the products in the beta. And he sent us an email the day before. He said, you know what would be really cool? You know what would be really cool is if a browser could tell in real time what websites were bad and block you from going to them. But, you know, that's actually a really cool idea. So we built it overnight, and the demo we showed them the next day had that feature. And we got the best review I think he's ever given it. Because it was his idea. Which actually ended up being the killer feature of Netscape. It was sort of real-time blacklist of phishing and malware websites. And same thing with OpenStack, right? Those 17 days changed everything we were doing in NASA and a lot of other places. I hate this slide. This is, I promised one graph, right? So this is the business value graph. I don't know how many of you are business people, but have you heard of IoT? Yeah, sort of the Internet of Things. You're all holding a phone. Half of you are holding phones. Those are the things we're talking about. We're also talking about the sensors in jet engines, being able to find planes and then crash into the ocean. Fitbits, smart toasters. How many of you are old school network people? You remember HTTP, TCP? The coffee pot protocol? Yes. That's the things we're talking about, internet attached coffee groups. Yeah, I wanted to tie back to what PLUMgrid was saying earlier and why there is this incredibly intense fixation on network performance. So I didn't include the graph I usually include, but it looks like that same shape. Everyone's heard of Moore's Law? We're all smart, comp-sci people, yes. Computers get faster. It's exponential. It's awesome. Schreider's Law is that storage gets cheaper and more dense. Not the same as Moore's Law, not quite as fast, but almost equally awesome. Nielsen's Law, not named after you, is that networks will get faster, but not very often, essentially linear. And what this leads to is this thing called the mobility gap, which is that we can compute more, store more data, produce more data by computing against it in a viciously exponential cycle, and our ability to move the data is essentially stagnant. The cost of moving data versus the cost of processing it or storing it is getting worse and worse and worse. And you can see this happens like breeding bacteria in a jar, right? Day 1, you can't see anything. Day 2, you can't see anything. Day 3, you can't see anything. Day 4, they filter your entire living room. So you can tell by looking at the math that within a couple of years, not having high performance networks destroyed every cloud on the planet that we tried to build. But it's not obvious until it's too late, which is why the focus on the network as being the most important part of every cloud deployment comes out. People go, well, I don't know, when we only had 7 or 8 servers and we had a couple dozen VMs, it didn't seem so bad. And then we had a second rack and it was a little slow, but it seemed okay. And then day 3 is like, I can't move packets. I can't run traceroute to figure out what's broken. It's double. And I can't get people to stop trying to access the cloud for an hour so that I can figure out what's wrong. Because it's a cloud. And then you think about that as being just about servers and VMs, which it is today. And you say, oh, by the way, now there's 7 billion people, each of which have 100 connected devices, each of which is sending us a piece of data every second. It's called a DDoS when you do it by accident. I was going to tell another story, actually, this painful story. I'm essentially an idiot. I just started making mistakes earlier than most people. I started programming when I was 6, so by the time I'm my age, I've made more mistakes than most of you will make in your entire career. I just make mistakes at an extremely accelerated pace. So when we were doing the Netscape browser, Right before that, we did a browser toolbar, one of those super hateful and annoying things for AOL that they bundled with AOL Instant Messenger, which had 97 million active users. And about half of them opted in. Checkbox that says, do you want to block pop-ups in your browser? I think install checkbox. And we built stats tracking into this browser where every day, once a day, at a random time, this browser toolbar would call back to our stats collecting service and tell us how many times the search box had been used and how many times the weather button had been used and all this crap so that different AOL divisions could get paid. And I wrote the stats tracking code, and it was one of those contracts where it took us 6 weeks to negotiate the contract, and we had 4 days left to actually write the app and ship it. So we wrote this entire browser in 4 days, of which 4 or 5 hours was stats tracking code, and it was in the middle of the night. I was tired. And so maybe you write C. You know what happens when you redeclare a variable inside a loop? So 9 p.m. every day, every single browser toolbar in the world started trying to send data to our data service, which is a 36 million person DDoS of all network connectivity we had to Vancouver Island. For weeks until AOL would let us roll an update. So DDoS hurt, and they're really hard to deal with after the fact because they're out in the wild. Internet of Things plus cloud is just a big-ass DDoS waiting to happen, which is why I'm so keen on things like built-in load balancing in Foundry, because at least then you know that there's a code base you can get at, that all of your apps are using. You can go patch. This was not specifically about DDoSes. I tweeted earlier, I mostly say things on Twitter and then I put them into slide decks later. So I said earlier on Twitter that people keep behaving as though there is a future normal that we're going to get back to. And no such future exists. And this is particularly prevalent in IT, where people keep behaving as though we've gone through this brief transient thing where everything's changing really fast. And we just got to sort of make it through, learn a couple new things, and we'll go back to normal. And we'll be in control. And so I have people tell me, I have a customer tell me this afternoon, that we're going to wait and get IaaS sorted before we start on PaaS. And I said, you guys are idiots. I'm not actually very popular with our sales team because I'm usually very mean. You're retarded. The problem with that plan is that the rate of change in 2015 will be double what happened in 2014 in the same industry. And that was double the year before. And that was double the year before. And that is going to keep getting worse. So when you look at the applications you will be managing in enterprise IT at the end of the decade, 90% of those have not yet been written. Which means the huge ass problem you think you have today, the 500 or 600 enterprise apps you have that you're worried about, should we migrate them, should we update them, how do we put mobile or API interfaces on them, those don't matter. By the end of the decade, that will be less than 10% of your problem. So if you don't figure out how to solve the problem that you're creating tomorrow morning, you're never going to catch up. You become Barnes and Noble. or a yellow cab in 18 months. Or what almost happened at the NYSE. And I got to see Larry Leibovitz, who was the COO at NYSE, which is weird because he's Charles Stewart's brother. You know that? Odd. Your town is weird. So he was talking about transformation of NYSE when the industry was deregulated. He said, look, when I started, I figured that we were 18 months from extinction. NYSE was going to cease to exist because NASDAQ and everyone else had suddenly become our competitors, and we had a 100-year legacy of crap code that we didn't know how to let go of. And our problem was entirely cultural. And so I'd say, we need to modernize this app. And the team would come to me and say, well, we can't stop supporting any of these APIs or legacy core things because we have customers using them. So fine, you're fired. Somebody find me the new person who's going to modernize the app. And he literally fired every single person who said no until they started fixing things, which is the only reason that NYSE exists. And it's that sense of urgency that keeps people in business. And it was the lack of that sense of urgency that put Barnes & Noble out of business. And I think we're going to see a bunch of other very, very large companies disappear. The S&P 500 has had 40% turnover in the last decade. On its current pace, it will turn over 75% in the next decade. The largest companies in the world stopped being the largest companies in the world. Many of them went out of business. And the new companies didn't even exist. That is because of the rate of change, which is why going fast is the only way to stay in front of that kind of change, right? So this is Lao Tzu said that was sort of apropos. Yeah, I have a little rant about Bitcoin containers. I don't think I need to actually go. I said various things on Twitter about how it's not the containers that are interesting, right? When they invented containers, the people that were really excited about containers were the people selling containers. The railroad company sells you the ability to move your crap somewhere else. FedEx also ships things in containers. They don't talk about it. They talk about the form factor you care about, which is the salt of the envelope that you use. The fact that it goes in a container later on does not matter. What makes containers interesting is cranes and trains and boats. I said earlier, OpenStack and Foundry are not competitive. I wanted to revisit this very briefly. If you run IaaS, you are managing, let's call it virtual machines, whether they're remote or not. The promise that your IaaS makes, if it's any good, is that it won't peak. You get a virtual machine, you do what you want. Install the OS you want, install the software you want, configure it how you want. There's one data channel in and out, which is the metadata channel, maybe it's a big drive, properly, that's it. It is opaque to the system. And orchestration, if it happens at all, is post-hoc. It happens after the VM boots up. It happens after there's an OS, hopefully, maybe not, in case of ironic configurations. And system changes are imperative. So you're making commands that say, launch a VM, bind an interface, terminate a VM. And even if you split those out, notionally, they are imperative commands. In a PaaS, your unit of value is the manifest that declares the state of the world that you want. It's usually YAML. And it might use containers, it might not. The containment vehicle, whether it's a process or LXC or C groups or bare metal or VMs, remember Foundry uses both VMs and containers. It's transparent to the app. The app is allowed, the platform is allowed to do whatever it wants in there to express your manifest and repair it at runtime in any way required to keep it in the desired state. It is a state machine looking at actual state, desired state, and making changes continuously. It is not an imperative, happens based on commands system. And it owns the entire lifecycle of that app, which means if you go and say, hey, I want more, I want a different version, I want to bind this now, I want to, what you're doing is you're changing the declaration of desired state. And then the system itself is taking commands on your behalf. It's a different paradigm. And I looked at I was trying to build a PaaS initially. I did not take my PaaS and turn it into OpenStack. I stopped working on PaaS, wrote OpenStack, and then went back to PaaS. Because PaaS is a totally different object model. It is a different worldview. It requires different primitives. OpenStack, by the way, doesn't have a PaaS implementation yet. Right? Most vendors use one to deal with orchestration and bare metal, but it doesn't use consistent state except for databases. Every good PaaS has access at the center, whether it's etcd or console or serve or something. Raft in some cases. Because you can't deal with state transformation without distributed consensus. Does that make sense to anybody? This is what PaaS does. None of this necessarily involves VMs. You shouldn't have to think about VMs as a developer. You're saying, I got some stuff, make it run. And it deals with, oh, by the way, this should be on lots of different servers because AJ matters. And it should be using different VMs and different racks on different power supplies because AJ matters. The number one thing we waste operational resources on is trying to see whether or not things are broken. Waiting for the pager. All right, I don't want to talk about the slide. It's boring. Has anyone heard of microservices? Few. Okay. There's this new idea that's not that new. Netflix is the one that really popularized this, which is if you are building a big project and you have a lot of team members, they're going to get in each other's way. You heard of Conway's Law? Conway's Law says when you build software, the architecture of your software will look like the architecture of the organization that built it. So if you have 4 groups, you end up with a 4-pass compiler. It's extremely true. Cloud Foundry itself is a demonstration of Conway's Law because it has 2 major components, because it has 2 big teams at the end. One under Derek Collins and one under Mark Bukowski. So you can have this on purpose, and this is what people figure out. They're like, well, we're trying to do Agile. We're trying to have these small teams, no more than 12 people, and we have Scrum Masters. And each team has to build a small piece, and then we've got all these little pieces. And the teams aren't all equally good, so some of them go fast, some of them go slow, so we've got to version the pieces separately, and then they got to talk to each other. We should just make that HTTP because we don't have a load balance, we don't have to monitor it. Oh my God, we invented SOA. Let's call it something else. That is microservices. SOA, it's good parts of SOA without XML. Yeah.
Adrian Cox said if your microservices all have to be versioned at the same time you update one of your microservices, it's SOA.
Yes. I will repeat that just for the record. Adrian, does anyone know who Adrian Cox is? The sort of chief architect of Netflix, guy who popularized a lot of the stuff. He said, if you have to version all of your microservices at the same time as each other, that's not microservices, that's SOA. And if they can be versioned independently, it's microservices. So there's 2 things, one called microservices, and the other is called 12-factor. You guys want to take 12-factor home with you because this is the #1 thing that will change your career. Just like if you got on the Agile bandwagon a few years back when you're like, oh my God, I can just 12 factors that right now is amazing. It's just 12 things you should do if you're building a modern app that are kind of, they seem obvious afterwards, and you're like, oh yeah, that sort of makes sense. But literally, good PaaS is designed to help you build 12-factor apps that maybe or maybe not are microservice-based. And a great PaaS, and I consider Foundry a great PaaS, does not require you to do anything that is PaaS specific. Let me be really clear about this. I have a bunch of GitHub repos of demo apps that I have built that I deploy to both Cloud Foundry and Heroku without ever changing a single line of anything. Config variables and not code, which is the way it should work. Blah, 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 blah. Everybody likes to write in every possible language now. How do you let them do that? Because if you don't let the cool kids write and go, they quit. They go work for someone else. But if you have to manage every language individually inside your organization, it becomes an unmaintainable pile of crap. So there's this happy medium, right? Give them a few cool languages, legacy languages, and try and keep it in balance. Same thing with data stores. Everyone wants to use some cool, different kind of NoSQL, USQL, Super SQL backend. Run it on anything you want. Cloud Foundry can be run on basically every IaaS, right? It works really well in OpenStack. I'm talking about that because I help write the interface layer, but actually a lot of people use it on top of vSphere because it's run on VMware and it seems to make sense. Our production Pivotal Web Services cloud runs on Amazon, which is very cheap. And there's other people using it on Google and Azure and all sorts of crazy stuff. Why do you care? How am I doing in time, by the way? I wasn't even, okay, I got 10 minutes left. It's fine. I'll talk for 3 and you can plug me with questions if anyone hasn't fallen asleep. Or we could maybe pass here to the people in the audience, make me way more interesting. We're out of beer. You guys have to go home.
That's why we're paying attention.
Gotcha. So there used to be this joke by people that were bitter, most of the people that used to work on OpenStack, that OpenStack was just good for the parties. I used to throw the best parties in OpenStack before I met money. But by which I mean the community got so large I could afford to throw a party that size and these things would go right. Anyone go to the HP party in Paris? 6 blocks of Old Town Paris turned into a like 1920s carnival.
$1 million later.
Exactly. Only HP had that kind of money for a place. It was amazing. Okay. I want you to internalize this. If you don't believe it, I want you to immediately start arguing with me so I can convince you, because I want everybody to go home and repeat this to everybody you know. People do not use open source because they want to change the source code. That was true in the 80s. 99% of the people that use 99.999% of the people that use open source in the world will never change any of the source code of what they use. How many of you have customized RHEL? I'm not talking about recompiling your kernel. I'm talking about writing like a change. Yeah, nobody. I did it once. I don't recommend it. It's really hard to support afterwards. The same is true of OpenStack and Cloud Foundry. Most users do not like it because they think they get to change it. They like it because they believe it is easy to get other people to change. And they don't do it because they think that open source is magically cheaper free. That was what everyone believed 10 years ago. We'll go to open source because it's cheaper. Nobody realized, and this is if I ever came up with one clever idea, it's this: open source forces people to do agile. We did not know this going in. But when you look at an open source community and you say, well, what makes it work? Well, there's these reviewers, and they're really busy, and they're generally impatient. Oftentimes, they're autistic assholes. And if you give them a giant patch, they will ignore you. And then if you beg an IRC, they'll swear at you and ignore you. If you give them a tiny patch, they'll probably review it in 10 minutes, like, yeah, it doesn't suck too bad, go. If you give them another patch the next day, they'll do the same thing. If you have test coverage on those patches, they'll probably accept them more quickly. You see where I'm going? You have a large community of people submitting very small patches at a high cadence. You just reinvented agile development. And by the way, it's all public. You kind of have to talk about what you're going to do ahead of time, otherwise no one will believe you, or they'll do it before you do. But you can't talk about too far out in front, otherwise by the time you get to that plan, the rest of the community's gone in a different direction. You just reinvented the agile backlog. Every single thing you have to do in open source to have a functional community creates agile development. That is why everyone likes it. That's why everyone keeps saying open source is a source of innovation. Well, how is that magically possible? Because people that work for free are smarter than people that charge money for it? I don't think that works. It's because when you're inside a large insular organization that is in the habit of being secretive, they are secretive from each other as much as they're secretive from the rest of the world, which slows everything down. Yeah. The other thing is a healthy open source community always guarantees multiple things, which is why I tend to be mean to certain open source communities, like, yeah, source code is free, there's one vendor there, that's not open source. Open shit. And literally, in most cases, you want to buy, if you're a rational customer, you want to buy the open source from the vendor that does most of the work on it. Sort of makes sense. You're like, well, if I find a bug, who's going to fix it for me? Probably the person who fixes most of the bugs. But having other plausible vendors will keep them honest. This happens with Linux all the time. Everybody buys Red Hat. The fact that you can buy SUSE or Canonical if you're on Ubuntu keeps Red Hat from being total assholes. So, I mean, and actually this dynamic is how I look at every open source project today. Now, and this is why I'm on the Open Platform Advisory Board. And like all of these other SDN things, I look as well, are there multiple vendors willing to sell it? Is the license structured so that it's forcing agile and a natural community can emerge that has a piece of innovation? Yes, good. No, go home. So much easier to evaluate than looking at like, well, what's the license, the CLA, reading CLA details? Oh my God, we once spent 3 hours out of an 8-hour OpenStack board meeting discussing the difference between the DCA versus CLA, with lawyers arguing on the side of the table. I actually wanted to kill somebody. If you ever do that to other people in your organization, they probably will kill you. Even the lawyers hated that conversation. All right, we talked about this. This is the last thing. This is not for you to understand. You already get this intrinsically, but take this home to your pointy-haired bosses and be like, no, going faster is less risky. We spent years thinking that going slow was safe. Right now I talk about, oh my God, the rate of change is going to crush you for data and you're like, well, but I have to go slow that you can figure out how I should respond to the change. No, you don't. You need to make the smallest possible change and see what happens. Because it turns out we're humans. The only thing we learn from is shit we fuck up ourselves. So screw it up as quickly as possible, learn from that experience as quickly as possible, and then make a new mistake. Hopefully, you make a different mistake the second time, the third time, the fourth time. If you repeat the same mistake over and over and over again, you're going to get fired. All right, this is the last of two slides. Why would you care? Because if you deployed OpenStack and now you're like, I didn't have customers, oh, how do I get people to use it? It feels hard. Well, it's because I only wrote it to run Foundry, not to have people consume APIs. And nobody else has really fixed that problem either. I mean, come on. Developers don't want to use OpenStack, and for very good reason. They don't want to think about infrastructure, virtual or otherwise. The fact that it's virtual does not make it more sexy. It's equally annoying to have a virtual hard drive as a physical hard drive. 500 looks really good on the CD. Honestly, we pay people way too much in the ecosystem, but that's going to continue for a while. Same thing that happened with OpenStack for the last 5 years. Charge a whole bunch of money and move into that space. I didn't talk about Bosch, but there's this ecosystem thing that's happening now on top of Cloud Foundry, similar to what happened with vendors inside OpenStack, with Neutron, Super plugins, etc., where everyone from Jenkins to Cassandra to Redis and Rabbit are packaging their software to be deployed on top of Cloud Foundry. It's like the new cool middleware. Which if you have complicated SaaS software, and I hear this people all the time, we built a great SaaS business, but we can't sell to government, can't sell to regulated industries, because it's got to go behind your firewall. It's just too hard to orchestrate. Our solution is complicated. Okay, well, is it too complicated to make a Bosch manifesto? Because Cloud Foundry itself is 48 running VMs talking on 3 different kinds of message buses. Way more complicated than OpenStack, and we can install that in one click. I'm sure your software is not worse than that. All right, OpenStack plus, if you guys work in the OpenStack world and want to help, these are some things we're doing. Make Neutron not suck. Make Rabbit better. I know Rabbit is in the center of basically most OpenStack environments. We just recently inherited Rabbit on the Cloud Foundry side of Pivotal, so we're going to make it better for OpenStack. And OpenStack Congress is one of those cool up-and-coming ecosystem things. We're working with those guys to make unified policy work. I want to get involved in that. Now, the last thing you have to all do, I'm going to stand here and wait while you do these things on your laptops and phones. You sign up for some mailing list from IRC, you're going to 12-factor, that's the link. You're going to come to one of these 3 workshops, because Clark is actually a super nice guy. I don't know if you can go to him, but cool guy. I don't know when the next Cloud Foundry Summit is. I think it's in June-ish. But it will also have great parties. No, they haven't said it yet. It has a lot more users than OpenStack Summit. It's actually more user case study, more discussion and future roadmap, less technical sessions. I think that's just the balance of the community at this point. It's easier that way. Try Pivotal for free, which is Cloud Foundry. Sorry, Pivotal Web Services, Cloud Foundry, free 30-day trial, go kick some tires. Learn to use the CLI, or the dashboard, or whatever you want. And then you should join this Meetup community if you're not already a member, or the Keep Cloud Foundry one. Yeah, both. Join this one too. I might have 30 seconds left for questions. Oh, look at that, I got like 4 minutes. I have till 10. I'm not going to stand up here for like 42 minutes. We're out of beer. Questions? I can tell gory stories about the early days of OpenStack. Yeah.
All right, so you were talking about users being involved in the development process, mailing lists and stuff. One of the things that has plagued the OpenStack projects is part of the developers decided what features were going to be in a development stage as developers work. We started changing that to last few summits. We started tracking and design summit, start collaborating with each other and the other PTLs. What's the process from an operator standpoint?
I didn't get enough buy-in to what the concept was and the fact that it also needed to onboard in. And we didn't do a great job of seeding the initial user community. Basically, in hindsight, the users that we wanted involved were the most busy people with the least time to be involved, right? So the nature of a user using project is they don't have a lot of time to be organized user communities. So that didn't work perfectly. And I think the idea in most of the community was that the vendors themselves would be the voice of their users. And really the problem with that was that most people were using trunk and not using vendor distros for a number of years. And also that a lot of the vendors didn't really get along terribly well outside of the actual collaboration community. In the business ecosystem, they're all pretty good to each other. So I don't think it's inherently flawed to say, the vendor should take feedback directly from their customers. I know that actually works pretty well at Pivotal. It's a big chunk of my role, right, is to run around and say, well, what do you want to do that's different? The CAB has been working pretty well, so the Foundry Advisory Board, Community Advisory Board, is mostly proxies for users, and then by that I mean the professional services orgs that are doing deployments. And so they've been bringing really useful feedback. We have folks like Bloomberg, whose repos are public of like what they've been doing with CF, and so they are a generally very vocal advocate of saying, and change this, change this, change this. Yeah, what else? I think the foundation governance model is probably going to get expanded for how do we really make sure that users are well represented. And we're sort of waiting, but we're kind of waiting for the executive director to start so that we can announce who that is and sort of take control of, here's where governance goes and stuff. I'd say the mailing list, the Cloud Foundry mailing list and the Bosch mailing list are a great place right now because I know all the product managers of the teams that are building it are on those all day. Right? And I've seen it work really well. You can also use like GitHub issues and pull requests and also like most of the channels work reasonably well in terms of getting things into the backlog. Now, fighting for prioritization in the backlog is the same challenge that OpenStack has. You have to convince somebody who pays developers that your request matters. And it's really driven by the voices of the people that are using it the most or the voices of the people that are paying the most. Sometimes that's true, the same, and sometimes it's not. As an example, Baidu is a great Cloud Foundry user. It's 1 billion page views a day hosted on Cloud Foundry. But they do it entirely from open source. They don't really speak English, and we have no idea what they're doing. So we don't really take feature requests from them, and they don't really send pull requests. So it's not, they're a huge user, but not a community member. Whereas we definitely got community feedback from Swisscom, and up until very recently, they weren't really directly engaged in either the community or with any of the vendors. They were sort of doing their own thing. But they were using a post-serve shop that was on the CAB, and so we had a back channel, and things they built got pulled into the CAB board meetings and put into incubation and people saying, yeah, those are cool tools, let's support those in the community. So I think it's something we're more aware of. I mean, look, James Waters, in a lot of the drafting process, because he's a good friend of mine, he's like, I'm just not going to do any of the things wrong you did. I'm just going to not do it the way you did it with OpenStack, and we'll be fine. Certainly on the user side, I think that's probably fair. Yeah.
Now that the foundation has been created, do you see any loosening up of how a random developer can participate?
It's a good question. I think if a random developer is willing to go through the usual open source ringer of submitting a pull request and having it rejected comments, like we don't have test coverage, or this doesn't make any sense, or this is a very specific case, why don't you build a general case, or all that kind of stuff. I didn't ever go through the JoJo process and I got pull requests accepted.
So I think, yes, as far as making it easy, I doubt it. I don't think the goal is actually to have it be easy, to be honest. I think the goal is to maintain code quality. And those are kind of a natural balance. And I think in the long term, that's the better balance for the community. It's harder, but it means more. That's probably a better thing. It's certainly pretty easy to work on a side thing that's related. I mean, I would say building new services and build packs and CLI plugins is all really easy. They don't have to land in Cloud Foundry trunk. Put them on GitHub and people use them. And in fact, because the Cloud Foundry.org website is a community asset, it's really easy to submit pull requests to the website and document that you have these other plugins, right? I've written a couple of build packs. The CLI plugin framework just landed, and now people are doing cool things with this new plugin came up called Seed. It's like, oh, when you first install Cloud Foundry, set up forms and spaces and launch a bunch of apps as a plugin to the CLI. That's pretty cool. And that was totally outside core. And then I think there was a starting link contribution, Cloud Creator contribution, I'm not sure. So yeah, certainly, and that in a sense it looks more like the WordPress community, right? Where almost nobody would automatically contribute to WordPress core, but everybody writes plugins. And there's a big plugin directory, it's really easy to find them, and themes, etc. I think it'll probably be that way for a while. I'm staying entirely out of governance this time, so I have no involvement at all with the foundation, other than being on the advisory board. You guys are barely awake. Yeah.
Yes, as a continuation of that question, is the dojo process intended at a corporate level, like company sponsored?
Yeah, and I think dojo, to the best of my knowledge, is a minimum of 2 developers. Like, it's really hard for the core teams to be like, oh, yeah, let's just add one random person at a time for weeks at a time. It's a little easier to say, we're going to have 2 come from Syscom, we're going to have 2 come from AT&T, we're going to have 2 come from GE, or whatever, or 8. Yeah, I mean, there's a link somewhere in Foundation docs on the dojo process and how it works.
Hey, Josh, quick question about how you see the future of OpenStack and Cloud Foundry coming together. Do you think that the emergence of a standard PaaS will help focus the interfaces, and how do you see that evolving in the next couple of years?
Yeah, it's a great question. I tweeted the other day that I think by the end of the year, every major OpenStack vendor will also be selling CF. I mean, a lot of them already are. You know, Randy Bias used to push all the time on the board meetings that we should define standard use cases for OpenStack. And my perspective was always it's too early. We're not ready. But I think we're actually getting pretty close to ready now, where we can say, well, we have a bunch of lessons learned. There are use cases that are well fit for, you know, key-based template orchestration. Some of those are like standing and Hadoop or whatever. There are use cases like running a PaaS. There are sort of VCR takeout use cases where all you want is sort of a cheaper, better vCenter. There are the scientific commuting use cases like what CERN did. I don't think anyone else will ever do again. It's insane, but awesome. And, you know, we have maybe a dozen. And a dozen is still a lot to deal with, but it's down to a manageable number. Certainly Intel's work on the sort of winning the enterprise working group and some of the stuff has been helping to clarify what these use cases are. And now I think it's easier for the OpenStack vendors to be like, no, here's some use cases. And PaaS use case, we got Cloud Foundry, and the sort of takeout use case, here's our better version of Horizon, the better dashboard, right? If you're doing OpenStack at the edge, which is what a lot of the telcos and cable guys are doing to look at NFV, that's a really interesting use case that I don't think will mature for another 2 years, but maybe we have a bucket of good use cases that are coming later. And maybe that's, you know, plus CF or not, but they're certainly working on it. OpenNFV is working in that space and so on. I think the communities are going to get a little closer together, but not tremendously. I mean, it's like LAN, right? Linux and Apache and MySQL and PHP, totally different communities. Certain amount of overlap. It was actually never even packaged well, right? As a get a LAMP download.
I mean, XAMPP did it for Windows, which was horrible. No one used it. Or used a bunch of apt-gets. But the fact that it was a concept as opposed to a package was really powerful. I started calling this Coda, Foundry, OpenStack, DevOps, and Agile, right? Which I think also Coda is funny because it's the piece that comes at the end of a piece of music that actually ties it all together. I don't know if we'll end up saying this is Coda Stack, but it could work. It's a four-letter acronym. Everyone likes four-letter stacks. Did I sort of answer your question before I sort of wandered off some ranty thing?
Yeah, I think so.
Just one more question, and we're out of beer, people are exhausted. Go ahead, Dan.
Thank you. Taking into account your metaphor of containers, what are your thoughts around Rocket and Docker?
So this is where usually I would get much more drunk, and then we'd have a very personal discussion, which is what I did at the...
Still some wine left.
Yeah, what I did at the Colorado meetup. The way I think about open source is usually not about the marketing message, because I think that isn't very interesting. It's not really very true. I think it usually boils down to the language and the people. And even in a really, really large community, there are a very small number of people that are key influencers. And the culture of the community as a whole ends up being a mirror of the key influencers. Right? I know Solomon really well. I have a funny photo of him and I on a panel at Structure when he was doing DocCloud, maybe before Docker was spun out. And I know Alex Colby really well because Rackspace bought CloudKick right before they bought Angel Labs. And I think most of the drama in the Docker community comes down to understanding Colby's personality and Solomon's personality and their relative histories, right? In the sense that Colby was a YC-funded startup that sold early, and so he's not desperate for money, but he has a lot to prove that he could really build a giant scalable business. Solomon kind of failed to build a PaaS, had this last-minute spin-off that was enormously successful. He hasn't had an exit yet. He's really raised way too much money. So he's like, over his head in a certain sense. And some of his defensiveness around Docker, having been a sort of founding CEO, raised a bunch of money, that just comes from money pressure. That's what it looks like to me from the outside. It's like, dude, he has raised way too much money. He has no exit for Docker except being a billion-dollar company and has no idea how to get it. Except by owning things that he can't own because he told everyone they were free. And Colby's like, I'm just going to build a company out of my understanding of how to do great marketing, which I got an up-close, paid-for tutorial watching Rackspace do OpenStack. And I'm going to do that off of other people's code. So, I mean, I think there's a bunch of, now, they're both technically very smart, right? And remember, we look at CoreOS as being the folks who wrote etcd, which is actually the secret sauce in everybody's PaaS, including Foundry. Docker didn't write etcd. Docker did really, really good GUI. So you look at Solomon's team, and they're like the really good UX people, where the technical underpinnings are like, well, there's no security, networks model sort of a hash, there's no consistent state guarantee, like it's sort of like, it's very pretty on the outside, and a little lacking in substance. CoreOS is kind of the reverse, sort of. So I mean, I had that slide about third generation containers and the fact that what we did at sort of Oregon and Garden and Diego is actually where everybody's trying to get to with containers, which is HA, stateful management, etc. I think the good thing about the launch of Rocket is that it has deflated a ton of the hype about Docker as being a magic solution that just rubs some Docker on it, which is really pissing me off, frankly. Because every conversation I get people, well, what about Docker? I actually did a slide deck. I'm going to open it up. Oh, what about Docker? And I did it like a year and a half ago. Oh, that's not my computer. Sorry. That's not going to work. Go look on SlideShare or do a search for McKenzie, but what about Docker? Because I sort of went like, guys, containers have been around since forever. The only lesson we really learned from Docker is that people are sheep and UI matters. Okay. I mean, we learned that people are sheep from OpenStack. That was mean. It was mean to me, so that's okay. Okay, I'm going to say one other thing. I sort of promised Clark I wouldn't say this, but I'm going to say it. when people say Docker, and say, well, we're thinking about Docker, what they're saying is, we're thinking about having unprotected sex with the internet. Do you think that's a good idea? And here's why. If you're using containers and you're not using a VM in this analogy would be a condom, the first time you run that container, it's going to have bus mastering access to the PCI bus. It's going to have SRIOD, it's going to have hardware access to bus mastering, which means you can poison the firmware of every single device plugged in. You could poison the VGA card, the network card, BIOS in some cases, and Intel TPM and TXT protection is not going to help you at all. The next time you reboot that machine, it is entirely off, and you don't know it. Use a condom. Jesus Christ, this is 2015. Now, this is not going to be a problem forever. A couple of years from now, there's new stuff coming out from Intel. We'll figure this out. We'll be like, oh my God, bus mastering was a bad idea. What were we thinking? Or every vendor I've just offended will come out and say, we have hardened firmware, and we are sure that you can't exploit bus mastering to reflash the firmware from an unprivileged user. Yeah, ironic is the same problem. This is why I still look at ironic is a bad idea. Ironic, I don't want to get into that conversation. So I think containers are a really, really important component of PaaS, as long as they're fully orchestrated and automated. But the BYOC model, the bring your own container model, which is what everyone says they're going to do with Docker, is a fucking horrible idea. Don't let people do that in your infrastructure. And the thing that Cloud Foundry does, which everyone says that's super prescriptive, is Cloud Foundry assembles the container image for you from the OS, which is stem cell, the build pack, which is language and framework, and your application code. And that whole assembly process happens inside. Now, with Diego, we've extended this, and we have this whole interface where you can bring your own containers. Please don't use it. Please connect it maybe to a separate build pipeline where you do your own image assembly process. Do not allow people to bring container images. That's kind of like the old, well, if you let random people walk up to your laptop and plug in a USB stick and run files. No. Okay, and random, but yeah. So that on the Docker story, and then that applies to Rocket as well, right? Like, or Warden, or any, I mean, Warden's slightly better, but still, don't bring your own containers. You guys probably want to go home. I'm just going to get more and more colorful with this.
And that's on video.
On recorded, on my back.
Where's that going to go up?
We're going to process it.